And final video of the week, Integrated Math 1 students. We are going to be talking about polygons and if polygons are congruent. So the last video we talked about angles and different angles that we could see were congruent using parallel lines and a transversal that cut through them. But what if we had two polygons and we wanted to see if if the two were congruent. And one of the ways we can think about that is through that sequence of transformations. And if you remember transformations, we had reflections, rotations, and translations. And just to kind of give you a little picture in your head, we had reflections, which we talked about were like a mirror image. So I have this shape on a plane that maybe looks like this. And then if I was to reflect it across this y-axis, it would look like this. So we would have a mirror image of that shape. And then rotation, we would have a shape, maybe another right triangle, and we would rotate it about a certain point to a certain amount of degrees. So that shape would be rotated. So maybe the right angle ended up on the top from the bottom by rotation. And then we had translation, which just meant a shift, where we took a shape and we didn't change, again, all these, we don't change our angles or our side lengths, we're just shifting them. So here's my right triangle, which, dang, that was bad. Here we go. Here's another right triangle. And I'm just going to shift it down over here. So I'm just going to actually move it down this way or shift it. And sometimes we went over 3, like right 3 and down 2, I think was some of the ways that you guys were using it in previous activities. So, and remember, again, we're talking about rigid, meaning that when rigid transformations, they don't change their size or shape, they are just moving into a different position. So which of the polygons below appear to be congruent, and what is the sequence of rigid transformations that demonstrates that congruence of the polygons? So I'm going to try what I did last time with my angle congruency here, and I'm actually, remember, I can't do it like that. I got to do it in all one motion. Let's see if I can do this nicely. Okay. So here I have the shape B. And I think that my shape B is the same or congruent as shape D. So, and I think it's going to be a rotation. And I think I'm going to rotate this around. So let me click on the actual shape. See, let me do that. All right. I'm going to rotate this around a certain number of degrees. Let's hit my rotate. Let me rotate at 90 degrees. And when I do that, that lines up pretty nicely, huh? Considering my drawing was a little crude. But yeah, it seems by rotating this around, it didn't change its size and its shape, but it rotated 90 degrees. So if I was to say, when you're doing your activity, which shapes were congruent, well, we can say that shapes B and D are congruent because they line up with each other. And the series of rigid transformations was a 90-degree rotation. And you can actually just say the word rotation just to know that we know that you're rotating it around to lay it on that other shape. The other thing that you should be aware of, these figures are drawn to scale. So it's when I highlighted this around and rotated it, it should have lined up on each other. So in your following activity, you're going to decide which other of these shapes are congruent. And then you're going to say the sequence of transformations that made those congruent. So it does ask you for each pair of the congruent polygons, what can you say about the corresponding angle measures and side lengths? And again, you need to consider the definition of a rigid transformation. Because I rotated this around, I didn't change its size, I didn't change its shape, I just rotated it about 90 degrees. So think about that when you are answering that question. So the next question asks us that if two polygons are congruent, then the corresponding angle measures are equal and the corresponding side lengths are equal. So conversely, if two polygons have equal corresponding angle measures and side lengths, then we can say that the two polygons are congruent with a sequence of rigid transformations where they map onto each other. So what we can say is if we took this triangle right here and we were given some information that the side lengths were 16 and this was 75.5 degrees, then if we knew that these two were equal, we could say that the two polygons are equal because they could map onto each other. Now, looking at this, they don't look equal. What we have to do is trust our numbers. And what do you have right now in your toolbox to verify what this side length is or what this hypotenuse is? And I think probably some of you have guessed it right now, the Pythagorean theorem, which is from Tuesday, which said a squared plus b squared, which is my two legs, is equal to c squared, which is my hypotenuse. So what you can do is verify those side lengths or the hypotenuse to verify that these two are congruent. The other tool you have is that triangle sum theorem, excuse me. And I can't spell. Hang on a second, guys. Triangle sum theorem. And what'd that say? That the angles of a triangle all have, those interior angles all have to equal 180 degrees. Do I have two angles on each of them? Absolutely. This is 90 degrees. This one has 14.25 and this has 7.75. So we could definitely find out if those are also congruent. So you can prove those two ways. The last thing I want to bring to your attention in this worksheet and what we're doing here is the whole point of talking about polygons that are congruent. We actually have a special symbol. And I think when I was talking about the angles, I would say angle A is equal to angle B, but I was using the word congruent. And congruent has a special symbol, which looks like an equal sign with a little squiggly line on top. That actually symbolizes congruency. We also mean equal, but congruency tells us a little bit more. So for example, if you have two triangles that are congruent, it can be stated that triangle ABC, which I will draw here, here's triangle, and here's a triangle. And this is ABC, is equal to triangle DEF. What we could say is it's congruent to each other by drawing it out this way. We draw a triangle, ABC is congruent to triangle DEF. So by using that congruent symbol, it tells me that the angle lengths are the same and the side lengths are the same. Now, the other thing that we talk about is that the order of the letters, the name identifies the sides and angles that correspond to each other. So say this is side length 2, side length 3, and side length 4. This would also be side length 2, side length 3, and side length 4. So when I say these are congruent, A, B, C, I'm also saying these are congruent, D, E, F. I correspond those side lengths and the angles to identify each of the triangles. So I'm going to do this one with you. Luke wants to write a statement to convey the two triangles are congruent. If he starts with this triangle MNP, so here it is, N, then P. So it's the 20 meters first, then the 16, then the 8. If he wants to write out that statement, he has to make sure that those correspond to this other triangle. So I know definitely it's going to go start with U, triangle U, because it's going to, there's the 20. Remember the next was the 16, which is W. And then the third side length was 8, which was V. So it's good to kind of trace it out. So I'll do it one more time. N, N, P. So we went from that 20 to the 16 to the 8. So again, the 20, 16 to the 8. So U, W, V. Don't be afraid to trace these out to give you an understanding. The other thing you can think about is that rigid transformation. How would I get it from here to here? Would I rotate it? Well, let's see. Here's that 8 degrees. If I rotate this around, or this 8 side, if I rotate this around, would this land on top? So if I took this square, let's try it. We'll try my trick here. You ready? I'm gonna carefully trace it out. And let's give it a rotate and let's see what happens. I'm gonna rotate it one more time. Doesn't quite add up, huh? Look at that. The 20 adds up, but not that. So what would I do next? So I did rotate it. It's almost there, but what do I need to do? I need to flip it. So it's going to be a rotation and then a reflection in order to get these to line up. And there's 20, 16, and 8. So remember that when we are writing these out, these congruent statements out, the letters have to match up or correspond to those sides. All right, and you'll get another chance to do this on this problem down here. Okay, I hope this was helpful to you. I hope you keep in mind rigid transformations. I hope you keep in mind that when you're drawing or when you're writing congruent statements, that those letters have to match up. And, you know, we're going to pull out these tools, Pythagorean theorem and triangle sum theorem. And the better you get those, the easier these problems will get for you. All right, that was it, kids. I hope you have a great weekend after this, and I will see you next week.